Okay, so we have another example of moment about a point, only that now we will have an example of moment about the point in 3 dimensions. It's pretty much the same, and it gets easier if we actually go and use the already given equation for 3 dimension moments. And before we start analyzing the problem, just review what's going to be the equation for that. So remember that moment, it's going to be a rotation. When we work in 3 dimensions, in 2 dimensions, we'll have that the rotation it's only about one axis. In here we're working with the x and the y-axis, hence the rotation it's actually going to be about the z-axis, which is actually the depth. Now, when we go and work in 3 dimensions, we will have a situation where we'll have y, x, and z, and it's possible that my object actually rotates about z, actually rotates about x, actually rotates about y. And it can go in both senses. For example, here, instead of going in the negative sense, which is clockwise, it can go positive, which is actually counterclock. In here, it's exactly the same. Instead of going to the clockwise, we go in the positive sense, which is counterclock. And in here, the same. We'll have different rotations. So instead of having only one distance times a force, we'll have a set of different distance and different forces with different directions. That seems complicated. However, it is not as complicated as it looks like. Let me just erase this part. We'll see that the equation that gives me the moment about any position is going to be given as the cross product of distance vector times force vectors. It has always been vectors. However, when we work in a 2-dimensional frame, those vectors are very simplified. So we can go only for distance times force. Here, we will have to make the decomposition of the vectors. Remember that the vectors d will have a dx, will have a dx component going into I, we'll have a dy component going into j, and we'll have a dc component going into k. The same as for the force vector will have a force x that goes into I, will have a force y that goes into j, and we'll have a force c that goes into k. Knowing that, this expression of moment can be written as dy times force c minus dc times force y that will deliver the component of the moment in I, plus dc force x minus dx force c that will deliver the component of the moment in j, plus distance x force y minus distance y force x that will deliver the component of the moment in k. That means into the moment in the x-axis, moment into the y-axis, moment into the z-axis. So that's going to be the expression we use to obtain the moments. That means that in order to obtain the moment about O, we require the vector d and the vector f. Having that clear, we can proceed for the calculation of these vectors.